Hello everyone, thanks for coming, and today we are going to do a review of week 8 functions composition, and the pigeonhole principle. So first, what is the definition of function? Rigorously, we define a function as a relation of two sets A and B. It is called a function provided that for all A B1 in F and A B2 in F, it implies v1 equals to b2, which means that for one a, small a in the set capital A, there is only one b that corresponds to A, that has relation with A. So the domain of a function is denoted by DOMF. So it is just A, the whole set of A. The image of function is denoted by image of F. So it is the values f of A for all small a in this big set capital A. So it is a subset of B. We have three specific special types of functions. The first is the injection, which is also called the one-to-one function. So that means for the function at most there exists at most one a such that f of A equals to B. The surjection, which is also called the onto function, indicates the functions such that for every b in the big set, in the capital B, the set, there exists at least one small a such that f(a) equals to b. So if a function is both an injection and a surjection, then we call it a bijection. So that means for every b in the big set capital B, there is exactly one a such that f(a) equals to b. Next, we learned what is a function composition. Suppose we have two functions, a from A to B and b from B to C. The composition G circle f is defined as G circle f of x is G of f of x. It's a function from A to C. Specifically, if both f and g are bijections, then the composition G circle f is a bijection. We have the association law. The composition of h and g as a composite with f is the composition of h and the composition of g and f. We can also define the inverse of a function for bijective functions. The inverse of a function is only defined for bijective functions from A and B. So it is denoted by f inverse, f minus 1. So if f(a) equals to b, then f inverse of b equals to a. Specifically, the composition of f and f inverse is the identity function of the set B, which means identity function of bx equals to x for all x in B. The composition of f inverse and f is the identity function of the set A. Note that if A does not equal to B, then IDA does not equal to IDB. We also introduce the pigeonhole principle. The pigeonhole principle states that if we have P pigeons and H holes, if P is greater than H, then there are at least P divided by H, taking the nearest integer, which is greater than this number, greater or equal to P divided by H, pigeons that have to share a pigeonhole. So there exists at least one pigeonhole that is shared by at least this number, the nearest number, which is greater or equal than P divided by H pigeons in this hole. With the pigeonhole principle and the definition of bijections, surjections, and injections, we can investigate cardinality or infinite sets. So if we can find a bijection between two sets and we say they have the same cardinality, this applies to both finite sets and infinite sets. For instance, the n, the set of integers, and the set of natural numbers, they have the same cardinality. They are also called countable infinity. The set of all natural numbers and all real numbers is called to have uncountable infinity, so its cardinality is different from that of n and z. We have the Cantor theorem, which states that for a set A as a power set of A, they must have different cardinalities. Thanks for coming.